Welcome to the finale of our lesson 6-6. This is part 3. We're going to be looking at the line of best fit. Now, to help make predictions based on data that we have gathered, we find a line of best fit. Some other things that you might hear line of best fit referred to as a line of regression or a trend line. We tend to use those interchangeably, so if you hear one, it could mean any of those three. They're all going to be the same thing. Now, one way that a line of best fit can be found is a method called eyeballing. When we eyeball to figure out a line of best fit, we first plot the data in a scatter plot like we were doing in video 1, and then we draw in a line that looks like the best fit for the data. Optimally, we would draw a line that divides the plotted values in half. In other words, we would have the same number of dots on either side of the line. Now, this isn't going to be feasible every time, but we do want to try and get it as close as possible to even numbers on the same side. Now, once we have drawn the line, then we want to find the slope and the y-intercept so that we can write an equation in slope-intercept form. Alright, let's jump in and look at an example. Now, we are asked to graph this scatter plot and then come up with a line of best fit. For the sake of time, I've gone ahead and drawn in these points. I want you to go ahead and pause the video and draw in these points, and we'll discuss this in just a second. Alright, just a couple things to point out real quick of questions you might have run into when you were making the scatter plot. I decided to go with a scale of 0.5 on my x's, so I was going up 0.5 each time, because I knew I had to go all the way up to 5. And I knew that I had a lot of decimals in between that were mainly 0.5. So that's why I chose 0.51, 1.52, 2.53, and so forth. Now for my hours, I looked for my highest hour. I saw I had to go up to 9. Now I did have some decimals in between, but if I counted by 0.5 every time, I wouldn't have had enough blocks to go through. So I went and counted 1, 2, 3, 4, 5, 6, 7, 8, 9. And for those times where I had to have a 0.5, like here where I have 1 and 8.5, I put that halfway in between 8 and 9 for my 8.5. Last thing to point out, we did have two data points that were the same, 3 and 7. Notice that if we were to plot that twice, it would be on the same spot. So really it's not going to look any different than just a regular spot. Even though it's happened twice, you would end up just putting the dot on top of itself. Alright, now the real focus of the video. We want to come up with a line of best fit. Now we want to draw a line that's going to kind of cut this data in half. And ideally we'd love for this to go between two different values. That way we can use those as ordered pairs when we're finding our slope. So you're going to want to take a ruler and you're going to want to move the ruler back and forth until you can come up with a line that looks like it's going to be about halfway. Now it might take a couple tries on this, so stick with it. And just because yours looks one way, your neighbor's might be just slightly different. There is no exact line of best fit for now when we're using the eyeball method, but we do want it to be fairly close. We ideally would like to go through 2 points, and we would ideally like to split it up into even points. Now if you look here, we have 1, 2, 3, 4 points on this side, and 1, 2, 3, 4, 5, 6 points on this side. And about 3 that were on it. We weren't able to divide it up perfectly, but this is going to be a reasonable line of best fit, as it is fairly close to all the data points. So now what we have to do is we have to write an equation based on this. So we need to find two things. We need our slope, and we need our y-intercept. The y-intercept is probably going to be the easiest to find. It's going to be where it crosses on the y-axis, up and down here. Now mine crosses at 9, so my y-intercept is going to be 9. Now to find the slope, we want to take 2 points from our graph, and we want to plug them into our slope formula. Remember, our slope formula is y2 minus y1 over x2 minus x1. I'm just going to move our y-intercept out of the way for now. That way we have plenty of room to work on our slope. Alright, so if I look through this, it looks like my point 1.5 and 8 is going to be one ordered pair that is on this line. And it looks like 4.5 and 6.5, this one right here, is going to be our other ordered pair. Now this is why it's helpful to pick 2 points when we're drawing our line and try and make our line go through 2 points. That way we can go ahead and find the values to plug in for the slope formula. We don't have to look and say, okay, this looks like it might cross there, but I'm not really sure. I'm not sure if that's the point I should use. This gives us 2 points that we know are in our data that we can use to do the slope. So we plug this into our slope formula. We're going to do 6.5 minus 8 over 4.5 minus 1.5. And this is going to come out to be negative 1.5 over 3. Sorry, had a moment of hesitation there. And when we reduce this, if we type this into our calculator, make it a fraction, this is going to come out to be negative 1/2. So our slope is negative 1/2. Our y-intercept is 9. Those are our key values that we're going to need. Remember, when we are writing a line in slope-intercept form, it's going to be in y equals mx plus b. Remember, our slope is our m, so y is going to be equal to negative 1/2 x plus our y-intercept of 9. So this is going to be our equation for our line of best fit. Alright, I'm going to go ahead and copy it so I can take it to my next slide. Oops, grabbed the wrong thing. Sorry there. Because we're going to want to use this in our next part of our example. So I'm going to copy it. And I'm going to go to my next slide. I'm going to paste it here so we can see it. Alright, so there it is. We're going to bring it over here. Now, we can now use this to predict other data points. So we want to use the line of best fit found on the relationship between Jake's homework time and sleep time to estimate how much time Jake would get if he had 7 hours of homework. If we go back to our graph, remember homework was our x value and sleep was our y value. So if we have 7 hours of sleep, we're going to plug that in for x. So we're going to do y equals negative 1/2 times the 7 hours that we are predicting for plus 9. Now, when we plug that into our calculator, we would get y is equal to negative 3.5 plus 9, which is going to come down to be 5.5 hours of sleep. Now, when using a line of best fit does give us a prediction for our data, if we are looking outside the data set, it's important to remember that this is still an estimate. It does not guarantee that he's going to get 5.5 hours of sleep. This is just a model that's predicting based on his past sleep patterns and his homework patterns. Remember, this is a line of best fit, not a perfect line that goes through all the data points. Remember, when we look back here, not every data point fell on this line, so it's not going to be a perfect estimation. Now, also another thing to consider is if you're making future predictions, a relationship between two variables may change in the future that would affect future predictions. Alright, that wraps up finding the line of best fit using the eyeballing method. We do have a more precise way to do this using calculators, and we're going to take a look at that in the application video. But that's going to wrap up everything for our lesson. So you have now completed our last video on 6-6. This is your last new video. Congratulations, you've made it. Please make sure you pick up your last application, application 6-6, and check out that application below. This is going to help you figure out a line of best fit using your calculator. Alright, see you guys in the application.